A builder needs a piece of wood in the shape of a segment of a circle for the purpose of building an arch. The piece is shown opposite. So here's the segment of the circle. C is the midpoint of the base, which is the chord AB of the circle. So point C is the midpoint of the chord AB. And AC is equal to CB, which is equal to x meters. So AC is equal to CB, and both of those are equal to x meters. CD is perpendicular to AB, so CD is perpendicular to AD, so it meets at a right angle. And CD is equal to h meters, so CD is h meters. R meters is the length of the radius of the circle that the segment is taken from. Part 1. Explain why the centre of the circle lies on DC. Part 2. The builder wants a formula for the radius r in terms of x and h. Show him that r is equal to x squared plus h squared divided by 2h. And Part 3. Having cut out a disc with the correct radius, describe one method by which he could cut the segment accurately. So Part 1, explain why the centre of the circle lies on the line DC. So this is the line DC. Okay, so let O be the centre of the circle from which the segment is taken. So I've drawn out the full circle, and I'm going to let O be the centre of it. DC contains the midpoint of the chord AB and is perpendicular to AB. So DC contains the midpoint of the chord AB and is perpendicular to AB, so meets at right angles. So we have a right angle, a right angle, a right angle, and a right angle, all 90 degrees. By the chord of a circle theorem, DC contains O, the centre of the circle. So DC must contain O, the centre of the circle. So just a reminder that this is Theorem 21, chord of a circle. Part 1, the perpendicular from the centre of a circle to a chord bisects the chord, which means cuts it in half. And Part 2, the perpendicular bisector of a chord of a circle passes through the centre. You don't need to quote this word for word, it's enough just to say by the chord of a circle theorem. Part 2. The builder wants a formula for the radius r in terms of x and h. Show him that r is equal to x squared plus h squared divided by 2h. So OD is the radius from O to D. So therefore OA is also the radius. And CD is equal to h in yellow. And OC, therefore, is going to be r minus h. So OC is r minus h. So if all of this is r, and this is h, then this leftover bit must be r minus h. So this pink line here, OC, is r minus h. So as AOC is a right angle triangle, so AOC is a right angle triangle, by Pythagoras' theorem, c squared equals a squared plus b squared. So we're going to label our right angle triangle C, A and B, making sure that the C is the longest side, the hypotenuse. So we swap the C for r squared, the A for x squared, and the B for r minus h squared. R minus h squared multiplied by itself, so r minus h multiplied by r minus h, gives us r squared minus 2rh plus h squared. Simplifying, we can cancel out the r squareds on either side, leave the x squared and the h squared on the right hand side, and bring us the minus 2rh over the equal sign. It becomes plus 2rh. So we get 2rh equals x squared plus h squared, and then we just divide across by 2h to get the r on its own. So we get r equals x squared plus h squared all over 2h. And that's what we were asked to show. Part 3. Having cut out a disc with the correct radius, describe one method by which he could cut the segment accurately. So he could draw a radius OD, so OD, the blue line, And measure a distance h from D along this radius. So measure a distance h from D along this radius. Mark on this radius the point C. So this point C. Draw a perpendicular to OD at the point C. So draw a perpendicular to OD at the point C. See construction 4 in chapter 12 on how to do this. If this line meets the circle at AB, so AB, then cut along this line. Just a reminder, this is construction 4, perpendicular through point on a line. So if we're asked to construct a line perpendicular to a given line L, passing through a given point on L. So this is the line L. So steps, method 1, using a compass and a straight edge. So you start by drawing the line L. Mark a point P on L. Using P as the centre and the same radius, draw 2 arcs to cut L at R and S. So we put our compass point in the centre, open up whatever radius we want, let's say for example 5 centimetres, and then we draw an arc on either side. Or you could just do a full circle, that's no problem. Using R as the centre and a radius greater than RP, draw an arc on one side of L. So basically just open up the compass point further than whatever you had it at originally. So from the point R, you're going to draw an arc, or again you could do a full circle, and without changing the compass, at the point S, you draw another arc, or again you can do a full circle if you want. So using S as the centre and the same radius, draw another arc to intersect the arc centre R. So that's just what I said there. Part 6, label the point where the 2 arcs meet as T, the point of intersection. Join P to T and extend. So join P to T and extend the line. PT is perpendicular to L. So PT is perpendicular to the line L. Indicate the right angles between PT and L. So just draw in your right angles. Method 2 is the set square. Draw the line L. Mark a point P on L. Say this is point P. Place a set square along L and line up with the point P. Using the set square, draw a line from P. This line contains P and is perpendicular to L. Indicate the right angle between this line and L. So obviously this method shows no construction lines, and it is much quicker and much easier, but sometimes it might be better to use this method so that you can see your lines of construction. Don't rub out your construction lines.